Okay, this is going over the motion test review guide for your test. The first question, what is the difference between distance and displacement? Remember, your distance is how far you have traveled. So distance is going to be kind of the amount of ground that has been covered. Or how far you've traveled. Displacement is how far you are from the start. Make sure you're kind of correcting yours as you're going through this. You can pause if you need to. Next, difference between speed and velocity. So speed is the distance divided by time. And velocity is displacement divided by time. So if I make the two triangles, I'll make the speed one up a little higher. So we've got speed, distance, and time. The next one we have velocity, displacement, and time. So you can see kind of the similarities and the differences there. We always, with displacement, have to add some sort of direction. Positive, negative, forward, back, left, right. Those are all good directions. The next one says, for the following, answer yes if an object is accelerating and no if an object is not. I'm going to skip ahead and come back to this because there's a question on the next page that says, what is acceleration? So we're going to jump down here to what is an acceleration. An acceleration is a change in speed, could be velocity, and or direction. So it could be changing both speed and direction, just changing speed, or just changing direction. So now that we have that, let's go back up to this question. For the following, answer yes if an object is accelerating and no if it's not. So if it's speeding up, that's a change in speed. So yes, it's accelerating. Moving around a curve, it's changing direction. Even if it's going at the same speed the whole time, if it's changing direction, it's accelerating. And then moving in a straight line at a constant speed is not. No change in speed, no change in direction. Okay, next one, we're going to compare displacement and distance to the right. A couple of things to remember here. Use my pointer. To the right is positive displacement and to the left is negative. So the displacement of A, and you may need to set like a ruler here to see, A is starting at 0 and going to 7 there. I didn't draw that very clear. So from 0 to 7 to the right, that's going to be a positive 7. The distance of C is how far did they travel. So they started C at 2 here, went all the way to 10, so that's 8. Then went back to 8, so went back 2 more, so that's 9, 10, and then back to 10, 11, 12. So they went 12, and we don't need direction because it's distance. Displacement of C now is start to finish, where they started, from where they finished. They started at 2, and they finished at 10. And they went to the right, so it's going to be a plus 8. So those that say displacement need to have a direction. Displacement of D starts at 9 and ends right there at 5. So 9 minus 5 is 4, but they went to the left, so it's -4. Okay, hope that makes sense on that one. Difference between distance and displacement. The next one says use the diagram to the right to answer the following questions. If it takes a runner 10 seconds to travel from A, wrong way, from A to B and ending at C, what is the runner's speed? So they went 3 plus 4, so they went 7 meters in 10 seconds. So 7 divided by 10 is going to be 0.7 meters per second. So that's B. If it takes a runner 10 seconds to travel from A to B to C, what is the runner's velocity? So velocity is displacement divided by time. So the displacement from A to C is 5 meters. So this one is 5 meters divided by 10 seconds. See how it's different? Distance is from here, the total ground covered, whereas displacement is just how far you are from the start. So 5 divided by 10 is 0.5, and we need a direction because it's displacement and velocity. So that would be B at 0.5. If it takes a runner 12 seconds to travel from A to B to C and back to A, what is the runner's speed? So that's distance, so it's 3 plus 4, which is 7, plus 5, which is 12. So they went 12 meters in 12 seconds. So 12 divided by 12 is 1 meter per second. That's A. And if it takes the runner 12 seconds to run from A to B to C back to A, what is the runner's velocity? Well, they started here and ended here, so their displacement is 0 divided by 12. So it's going to be B. So 0 meters divided by 12 seconds. Next, this part should go on the next page. It's referring to this stuff. It says indicate if the following motion diagrams are showing constant speed, increasing speed, or decreasing speed. All motion is from left to right, so they're always going to the right. This first one, the dots are evenly spaced, so if you look at it, these are all evenly spaced. So that would be constant speed, and they're all to the right. This one, the dots start spaced out, but then they get closer together. So if each one of these were a second, they're covering a lot of distance here, and then covering a less distance in the second part of this. So it's decreasing speed or velocity. And this is all to the right. So we'll just say to the right on all of these, because that's what it is. Sorry if you hear my dog whining behind me. And this last one is kind of the opposite of the one above. They start close together, and then the space between them increases. So this would be increasing speed or velocity to the right. It's helpful to think of these as a second and how much time is passing between each second, or how much distance, is passing between each second. Okay, next one. Draw a basic graph of our data from the CPO Speed Lab. Put time on the x-axis and distance on the y. Oops. So we've got distance was in centimeters, time was in seconds. And if you remember how our graph looked, it kind of went like that, if we drew kind of the exact line of it. Okay, so in this case, it wasn't that straight line that we did the best fit. It actually curved, which means the speed of the car increased. The slope got steeper and steeper as it went down the ramp. Okay, we already talked about acceleration, change in speed and velocity and or direction. This one, we talked about this a couple weeks ago. Are you currently in motion while sitting at your desk in reference to the school? So if you're sitting still at your desk in reference to the school, you are not in motion. But if we use the sun as a reference, yes, you are in motion because we're going around the earth, which we are on, is revolving around the sun. So we're moving in that fashion, but not in reference. The reference is the key part. If you're running around a track at a constant 6 miles an hour, are you accelerating? Okay, so no change in speed on that one, but you did change direction. So yes, because you are changing direction. So you are considered accelerating, even though you're moving at a constant speed. Okay, there you go. Make sure to rewatch, or you can pause, go back if you need more information. See you guys Friday.